Okay, so we're going to graph this function 1 over x minus 3. So the vertical asymptote is at x equals 3. Since the denominator is just an x, it's going to be in quadrants 1 and 3. But when x is negative 2, we need to put a hole. So if you go over here to negative 2, so the graph would look like this. We have our vertical asymptote at x equals 2 and our hole at x equals negative 2. Okay. All right, the next one, we want to factor the numerator and the denominator. So notice the numerator has the greatest common factor of x. So when I factor an x out of x squared, I'm left with x plus 1. Our denominator is an x. And now we can divide out common factors. But before we do that, what's the value of x that is going to be excluded from the domain? So x cannot be 0. So we're going to have something happening at 0, either a vertical asymptote or a hole. But then if you look back at our problem, we have a common factor. Factor means we're multiplying. We have a common factor of x and x. So since x equals 0 is removable, that means that x equals 0, we are going to have a hole. Okay, so let's make a sketch of this. Our function ends up being negative x plus 1. Okay. And when we go to graph that, you just have a negative out front. So this means we have a y-intercept of positive 1, and it's sloping downward at a slope of negative 1. But at 0, we need to make a hole. So we just do an open circle like that. Okay, let's take a look at this. This is a good picture of what it would look like. Looking at this, you can see that there's a hole at x equals 3. So what that means is that the factor of x minus 3 must be able to cancel. So let's figure out how we would do that using algebra. Notice the numerator is a trinomial, so we're going to do the x method. Two numbers that multiply to get 6 and add to get negative 5 would be negative 3 and negative 2. So this factors into x minus 3, x minus 2. So you can see the discontinuities at x equals 3, but because it's removable, that's what it looks like. And what we're left with is the line y equals x minus 2. So notice our graph hits the y-axis at negative 2. It's sloping upward at a slope of 1, and we put a hole right here. Okay. And the last one, our numerator has a factor of x minus 1. Our denominator, using the x method, two numbers that multiply to get negative 3 and add to get 2, would be x plus 3 and x minus 1, because 3 times negative 1 is negative 3. 3 plus negative 1 is 2. So we've got two problems here, when x equals negative 3 and when x equals 1. Both of those x values will make the denominator 0. And if you look at this factoring, we can divide out the factor of x minus 1. So that means x equals 1 is a hole. And since the factor of x plus 3 remains in the problem, that makes it a vertical asymptote. So if you take a look at the graph of 1 over x plus 3, you can see that we've got our vertical asymptote at negative 3. And you can see that we draw a hole here at 1. Okay, please put this in your notebook under removable discontinuities, and then continue with the agenda.